Welcome to Unit 6, everybody. So today we're going to be talking about congruent triangles. So hopefully by the end of the day, you'll be able to identify corresponding parts of congruent triangles, be able to identify congruent triangles and the theorem used to prove those triangles congruent. So if you don't know what the word congruent means yet, that'll be one of our vocab words, corresponding. And then we'll have our 5 theorems down there that we'll talk about. So similar versus congruent. I want you to kind of pay attention to this symbol. That symbol means congruent. Okay, notice all those pictures on that side, all the shapes are exactly the same, not all 4, but the pairs are exactly the same. They're maybe just rotated, moved around. Whereas similar is a little bit different, which we'll talk about later. There are a couple links there if you have any interest in watching those. You certainly don't have to, but pay attention to the sign and the fact that congruent is exactly the same. So what is congruent? Congruent is another word for equal, but congruent deals more with shapes, so equal measures of shapes. So if we're talking about side lengths, we're talking about the same length. If we're talking about angle measurements, we're talking about the same angle measurement. For the sides, we're going to use these dashes on the side. So like these 2 sides right here that I circled would be corresponding sides. So they would be the same length because they both have 1 mark. Whereas like the ones that have 3, those would be the same length. For angles, we usually use like an arc. So that signifies that those 2 angles are the same. If we have 3, that signifies that these 2 angles are the same. So again, congruent is just kind of a fancy word for equal, and it deals with shapes more than actual numbers. All right, so what are congruent triangle theorems? They're basically just shortcuts to prove triangles congruent. We don't need to know, if we think about triangles, we have 3 angles and 3 sides. We don't necessarily need to know that all 6 of those parts are the same. We have shortcuts that have been proven to help us prove whether triangles are congruent. So 2 triangles are congruent if they have exactly the same 3 sides and exactly the same 3 angles. But we don't need to know all 6 pieces of information. Usually 3 is enough. Doesn't always going to mean that 3 proves them congruent, though. We could have the wrong 3 pieces of information. So we need to make sure we have one of these 5 conditions. So the first one is side, side, side. So if 3 sides of one triangle are equal to 3 sides of another triangle, then the triangles are congruent. So if I look at my congruence marking, it may look something like this. These triangles do not have to look congruent as long as these markings are there. And vice versa, just because they look congruent doesn't necessarily mean they are. So side, 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 or SSS is our first theorem. Side, angle, side, or SAS is our second. Notice that the angle is between the 2 sides. So I would have one set of sides congruent, and then I would have an angle congruent, then I would have another side congruent. But notice that angle is between the 2 sides. I have angle side angle theorem. Again, notice the position of the S. It's between the A's. So for this one, if I had my 2 angles, sets of angles that were congruent, I would need the side between them to know that it's congruent. The fourth one, and probably the one that can get the most confusing, it's not necessarily, but it can be, is angle, angle, side. So for this one, it goes angle, angle, and then side. Okay, so this one would look something like this. Oops, I should have put maybe 2 here, sorry. Something like that. So it's going angle, angle, side, angle, angle, side. And the last one is hypotenuse leg. Now this one's only going to work with right triangles. So there's kind of our third piece of information. But we have a leg congruent to a leg, and we have a hypotenuse congruent to the hypotenuse, and that's enough. So SSS, SAS, ASA, AAS, and HL. Now we don't have an AAA theorem, and we don't have a donkey theorem. Not because they're bad words or anything, just because they don't work. It's not enough to prove those triangles congruent. We don't necessarily say that they're not congruent because we just might not have enough information to say for sure. So as I mentioned before, sometimes there might seem not to be enough information, but sometimes there is, which we'll talk about. Okay, so triangles must not just look congruent, they have to be congruent. So some of those things I'm talking about is like in this one. You see how they both, the triangle on the left and the triangle on the right, share a side. So even though that's not marked, It's part of both of those triangles. So if I looked at this, now I have angle, angle, side, angle, angle, side. So that would be that one. Now the congruent statement, I can start with a triangle on the left in any order I want. So maybe I call that triangle A, B, D. We always use 3 letters. But the triangle on the right has to line up with the same corresponding parts. In other words, if I started with angle A, notice it has the 2 arcs. That has to correspond to angle C over here. So I went A and then B. B has 1 mark. B has 1 mark in the other triangle. And then finally D. For the second one here, remember we talked about reflexive angles. So those angles, even though they're not marked, I know have to be congruent because they're across from each other in necks. So this triangle, if I look, if I just say, let's say triangle EFG. So I went, if I'm talking about the sides now, no marks, 2 marks, 1 mark. So I have to do that same order over here. So no marks, 2 marks, 1 mark. So I think it would be IHG. Then finally, something that we haven't really talked about yet is parallel lines and transversals. So if we have parallel lines and we have a transversal that goes through them, these, we call them alternate interior angles. So they're on this inside of the parallel lines, that's the interior, but they're on alternate sides of the transversal. So I have 2 sets of congruent angles there. So in this case, because I know all those lines are parallel, I would know this. And I also know that these have to share a side that's reflexive like we talked about in the first one. So those triangles, oh, I didn't mark the second one. Those triangles would be congruent by angle, side, angle. I have an angle, a side, and an angle. Same thing in the other one. So if I called this triangle KLJ, so I went no marks, 1 mark, 2 marks for the angles. That would have to correspond to MJL, so that everything lines up corresponding parts. This one over here should have been side, angle, side, because that's the order they're in. Side, angle, side, side, angle, side. All right, so for the first ones, we don't even need the triangles here. We have these congruent statements. So down here, it's asking me what angle is congruent to angle I. Look at angle I. It's the 3rd letter in that one on the left. So it has to correspond to the 3rd letter in the one on the right. So it would be congruent to angle K. For number 2, side DE, that's my first 2 letters here. So that has to correspond to my first 2 letters here. So that would correspond to DG. That little symbol above it means a line segment, or in this case, a side. Now for these ones, they want us to write the triangle congruent statement. So again, the first triangle I can write in whatever order I want, maybe Y, X, W. But now I have to make sure that the other triangle is written in the same order. So Y was the angle with 1 mark. That's F in this one, so that would match up. X, my second letter, was the one with 2 marks, so that would have to match up with G. And then whatever's left should just be my 3rd letter. For number 7, if I went triangle XYK. So XYK. So again, I went 1 mark, 2 mark, 3 marks. So that would have to correspond to X is 1 mark, Y is 2 marks, Z is 3 marks. So like that. So the order does matter, but this isn't the only other way you could write this. If I started this out as KXY, then all that's going to do is change my triangle over here. So K was 3, that would start with Z. X was 1, that corresponds to X. So as long as the corresponding parts match up, you can have them in any order. All right, so for these ones, we want to determine if they're parallel or if they're congruent or not. So right now we have 1 set of corresponding angles for number 5 and 1 set of corresponding sides. But we don't have an angle side or a side angle theorem. So if it doesn't fall into one of those theorems, I'm just going to say not enough info. They might be congruent. I don't know for sure, but there's not enough to say yes. Number 7 is right triangles. I have a pair of corresponding legs, and I have a pair of corresponding hypotenuses, or hypotenuse. So that would be yes, because of hypotenuse leg. For number 9, remember we talked about reflexes. So even though that side's not marked, I know it's the same in both of them. So this would be yes, and I have 3 pairs of corresponding sides that are congruent. So SSS. So these questions, and I'm going to zoom in a little bit, wanted you to say, okay, these are how these triangles are congruent. What other piece of information do I need? Now, number 11 is the trickiest one here, angle, angle, side. And angle, angle, side isn't always tricky, as we'll see in number 15. But there's a lot of right answers for this one. Because if I think about this, I could say, okay, angle T is congruent to angle L. That would be angle, angle, side, angle, angle, side. So that would work. But if I erase this, this would still work too, because it's still angle, angle, side. So I could also say angle T is congruent to angle K. Or I could start and say angle S is congruent to angle L. It's still angle, angle, side. So angle, angle, side is really the only one that you're going to have really 4 possible answers for in this type of question. So all of these would work. For number 13, side, angle, side, I have my 2 pairs of sides that I know are congruent. The A is between the S's, so I would need this angle congruent to this angle. So I would need to know that angle I is congruent to angle E. And then for number 15, here I have one of my angles already. We want angle, angle, side, so I can't put the angle up here because that would be angle, side, angle. So I would need to know this angle is congruent to this angle for it to be in that order, angle, angle, side, angle, angle, side. So I would need to know angle L is congruent to angle H. So you're going to practice the rest of these problems. As always, if you have questions, ask them in person or email. Find other resources if you need more help. Pause, rewind, whatever works for you. Hopefully you have a great day, and I'll talk to you soon.